Welcome to the Astronomy 95 channel. This is the NASA Top Stories episode 4. In this video, we will talk about air live coverage of Spacewalk, Untangling a Knot of Galaxy Clusters, Mars Sample Depot, Juno's 48th flyby of Jupiter, and more top stories of NASA. NASA's James Webb Space Telescope team has been selected to receive the 2023 John L. Jack Swigert, Jr. Award for Space Exploration, a top award from the Space Foundation. This annual award honors a space agency, company, or consortium of organ. The award will be presented at the Space Foundation's yearly opening ceremony of the Space Symposium in Colorado on April 17. Dotations in the realm of space exploration and discovery. Webb, the world's premier space science telescope, launched December 25, 2021. With its optics performing nearly twice as well as the mission required, Webb is discovering some of the earliest galaxies ever observed, peering through dusty clouds to see stars forming, and delivering a more detailed view of the atmospheres of planets outside our solar system than ever before. Webb has also captured new views of planets within our solar system, including the clearest look at Neptune's rings in decades. The Swigert Award, which pays tribute to NASA astronaut Jack Swigert for his legacy of space exploration, will recognize the contributions of the team members who designed, developed, and now operate the Webb mission. The installation of hardware for upcoming power system upgrades will continue during a spacewalk Thursday, February 2, by two astronauts on board the International Space Station. The 6.5-hour spacewalk is scheduled to start at 8:15 a.m. Eastern Standard Time. In order to finish installing a mounting platform on the 1A power channel as part of a planned solar array augmentation on the starboard side of the station's truss, NASA astronaut Nicole Mann and Japan Aerospace Exploration Agency astronaut Koichi Wakata will leave the station's Quest airlock on February 2. The two will finish the mounting platform installation that was begun during a spacewalk on January 20, relocate and install an articulating portable foot restraint for upcoming spacewalk tasks from the P6 truss, and if time allows, complete cable routing on the 1B power channel. The installation is a part of several spacewalks to add new International Space Station rollout solar arrays to the station's power channels. Scientists have discovered the first gamma-ray eclipses from a special type of binary star system using data from NASA's Fermi Gamma-Ray Space Telescope. These so-called spider systems each contain a pulsar, the superdense, rapidly rotating remains of a star that exploded in a supernova that slowly erodes its companion. An international team of scientists scoured over a decade of Fermi observations to find 7 spiders that undergo these eclipses, which occur when the low-mass companion star passes in front of the pulsar from our point of view. The data allowed them to calculate how the systems tilt relative to our line of sight and other information. Knowing the system's tilt relative to our line of sight is vital for measuring mass. As the companion orbits the pulsar, its superheated side comes in and out of view, creating a fluctuation in visible light that depends on the tilt. If gamma rays disappear from the data set of a spider system, scientists can infer that the companion eclipsed the pulsar. From there, they can calculate the system's tilt into our sightline, the star's velocities, and the pulsar's mass. Earlier models for this system, built from visible light observations, determined that it was tipped about 65 degrees into our line of sight and the pulsar's mass was 2.4 times the Sun's. NASA continues to evaluate data and learn more about the Space Launch System rocket's debut performance during the agency's November 16 Artemis 1 launch. Following an initial data assessment and review that determined the SLS rocket met or exceeded all performance expectations, SLS engineers are now taking a closer look at the Moon rocket's performance to prepare for the first crewed Artemis missions. Engineers in the SLS Engineering and Support Center at NASA's Marshall Space Flight Center in Huntsville, Alabama, collected more than 4 terabytes of data and onboard imagery from SLS during pre-launch and launch phases. SLS post-flight data have shown the RS-25 Engine's thrust and mixture ratio control valves were within 0.5% of predicted values. Through Artemis, NASA will land the first woman and the first person of color on the surface of the Moon, paving the way for a long-term lunar presence and serving as a stepping stone for astronauts on the way to Mars. This image was taken by the Hubble Space Telescope and features the prominent variable star V372 Orionis, as well as a minor companion star in the upper left corner. Both stars are located in the Orion Nebula, a massive star-forming area 1,450 light-years away from Earth. Orion variables are a specific kind of variable star that includes V372 Orionis. Astronomers may see these young stars' tumultuous mood swings and growing pains as erratic changes in brightness. The patchy gas and dust of the Orion Nebula permeate this image, which is common with Orion variables and V372 Orionis in particular. Data from 2 Hubble sensors are superimposed on this picture. Rich features of this region of the Orion Nebula were revealed by layering infrared and visible wavelength data from the Wide Field Camera 3 and Advanced Camera for surveys. Diffraction spikes that encircle the brilliant stars in this celestial image are another tiny mark that Hubble put on it. And strong point source of light, such as starlight, interacts with the 4 vanes inside Hubble that support the telescope's secondary mirror to create the 4 spikes that surround the brightest stars in this image. During the Juno spacecraft's most recent flyby of Jupiter on January 22, not all of the scheduled photographs were captured by the JunoCam imager. According to data from the spacecraft, the camera encountered a problem resembling the one that happened on its previous near approach of the gas giant last month, when the crew saw an unusual temperature spike after the camera was turned on in preparation for the flyby. The first 214 JunoCam photographs scheduled for the flyby were rendered useless, but, on this fresh occasion, the problem lingered for a longer amount of time. The mission team is analyzing engineering data from JunoCam that was collected during the 2 most recent flybys, the 47th and 48th of the mission, and is looking into the origin of the anomaly and potential mitigating measures. For the time being, JunoCam will continue to work normally while still being switched on. On March 1, the spacecraft will make its 49th flyby of Jupiter. NASA's Lucy spacecraft will add another asteroid encounter to its 4 billion-mile journey. On November 1, 2023, Lucy will get a close-up view of a small main-belt asteroid to conduct an engineering test of the spacecraft's innovative asteroid tracking navigation system. The Lucy mission is already breaking records by planning to visit 9 asteroids during its 12-year tour of the Jupiter Trojan asteroids, which orbit the Sun at the same distance as Jupiter. Originally, Lucy was not scheduled to get a close-up view of any asteroids until 2025, when it will fly by the main belt asteroid Donald Johanson. However, the Lucy team identified a small, as-yet unnamed asteroid in the inner main belt, designated 1999 VD57, as a potential new and useful target for the Lucy spacecraft. So, on January 24, the team officially added it to Lucy's tour as an engineering test of the spacecraft's pioneering terminal tracking system. The geometry of this encounter, particularly the angle that the spacecraft approaches the asteroid relative to the Sun, is very similar to the mission's planned Trojan asteroid encounters. This asteroid was not identified as a target earlier because it is extremely small. In fact, 1999 VD57, estimated to be a mere 0.4 miles in size, will be the smallest main belt asteroid ever visited by a spacecraft. The Lucy team will carry out a series of maneuvers starting in early May 2023 to place the spacecraft on a trajectory that will pass approximately 280 miles from this small asteroid. The first sample depot is finished by NASA's Perseverance Mars rover less than 6 weeks after it started to be built. Mission controllers at NASA's Jet Propulsion Laboratory in Southern California received word that the Perseverance Mars rover successfully dropped the 10th and last tube intended for the depot at around 5 p.m. Pacific Standard Time on Sunday, January 29. To guarantee that the tubes might be safely collected in the future by the Mars Sample Return Effort, which seeks to transfer samples from Mars to Earth for deeper examination, precise planning and navigation were required for this significant milestone. The rover has consistently collected 2 samples from rocks that the mission team considers to be important for science. In the Three Forks portion of Jezero Crater's depot, 1 sample from each of the pairs that have been collected thus far is now present. As part of the campaign, the depot samples will act as a backup set while the other half stay inside Perseverance, which will be the main vehicle used to deliver samples to a sample retrieval lander. Additionally, the rover left behind an atmospheric sample and a device known as a witness tube, which is used to check whether samples are potentially contaminated by substances that traveled with the rover from Earth. To ensure that they could be recovered safely, the titanium tubes were laid out on the surface in a complex zigzag pattern, with each sample being spaced out by between 15 and 50 feet. The researchers required to properly map each 7-inch long tube and glove combination's location to ensure that the samples could be found even if they were coated in dust, which added time to the depot creation process. The depot is situated on level terrain close to the foot of the elevated, fan-shaped ancient river delta, which was created over a lengthy period of time when a river emptied into a lake. The curvilinear unit is the name of one of the first locations the rover will visit during the new science campaign. The scientific team thinks the curvilinear unit will be a great place to look for interesting sandstone and possibly mudstone outcrops and to get a glimpse of the geological processes occurring outside of Jezero crater. At least 3 galaxy clusters are currently colliding spectacularly, as seen by astronomers. Astronomers are using data from the Chandra X-ray Observatory of NASA, the XMM Newton of the European Space Agency, and 3 radio telescopes to make sense of this chaotic scene. These kinds of collisions and mergers are the primary mechanisms by which galaxy clusters might expand into the enormous cosmic structures we observe today. They serve as the biggest particle accelerators known to exist. Able 2256, a massive galaxy cluster that is developing as a result of this collision, is situated 780 million light-years from Earth. This system's radio emission comes from a more intricate combination of sources. The first are the galaxies themselves, which produce a radio signal as a result of supermassive black holes at their centers ejecting particles into jets. Large filamentary structures, mostly found to the north of the radio-emitting galaxies, are also producing radio waves. These structures were probably produced when the collision accelerated particles in the gas over a distance of over 2 million light-years. Finally, a halo of radio emission can be seen close to the collision center. Another radio image has been created to highlight the weak radio emission since this halo overlaps the X-ray emission and is fainter than the filamentary structure and the galaxies. A group of propulsion development engineers at NASA has created and tested NASA's first full-scale rotating detonation rocket engine, or RDRE, an advanced rocket engine design that could significantly alter how future propulsion systems are constructed. This work comes as NASA begins to take the first steps toward establishing a long-term presence on the surface of the Moon. The RDRE varies from a conventional rocket engine by producing thrust through a detonation, a supersonic combustion process. This concept has the ability to power both human landers and interplanetary spacecraft to far space destinations like the Moon and Mars since it generates greater power while consuming less fuel than current propulsion systems. Over a dozen times, for a total of over 10 minutes, the engine was started. The RDRE achieved the greatest pressure rating for this design ever recorded while operating at full throttle, producing almost 4,000 pounds of thrust for over a minute at an average chamber pressure of 622 pounds per square inch. The Hubble Space Telescope captured this image of the Tarantula Nebula, commonly known as 30 Doradus. The Tarantula Nebula is a massive area of ionized hydrogen gas that is generating stars and is located 161,000 light-years away from Earth in the Large Magellanic Cloud. The region's brilliant, recently born stars appear to be surrounded by chaotic clouds of gas and dust. Hubble is familiar with the Tarantula Nebula. The hottest and largest known stars are found there, and it is the brightest star-forming zone in our vicinity of the galaxy. Recently, this region was explored by the James Webb Space Telescope, which turned up hundreds of newborn stars that had never previously been spotted. The first was made to investigate the characteristics of the dust grains that make up the black clouds looping across this picture, which are found in the space between stars.